threads. Oh, you see them right out. They swarf out of it. Oh, I left some nasty burrs in the back there now because of that crash. Oh, I've got a splinter in my finger. Nasty long one. It was in deep. Got it out. So that's what it looks like. It's not drawn over mandrel, it's welded tubing. And I've got that end, so fingers crossed it goes in the end of my only just. It's like 30 grams now. It turns inside it. So now I could do with grabbing it on that bit and turning this side down. Hopefully concentrically. I have to part it off first. Let's go for some parting. So I've changed the geometry of my parting blade and it seems to work a bit better. I don't get too many protesting noises coming out of it, and it doesn't store it. I stored it once, didn't I? But yeah. Let's see what this can do. Right, well that tool bit is not, it's just not cutting that, it's just doing, it's nothing, it's doing crap. So I'll try this little one. This just cuts like butter through everything basically. Don't know what I've chucked at it so far. Yep, so even at that high speed, it was quite happy doing that. Quite happy indeed. See what I got out to. $773. Alright, 860. Okay, 100,000. Another 90,000 in fact. Another 90. So this will be 5. That should be 40,000 out of it. Another 50 to go. $809. $809. So another 50 to go. That's it, I was getting carried away, getting into a routine of doing it, and it's like, oh, I think that's 50. No, it's not. I wasn't counting, just going for it. I got another 20 to go there. Look at that. Yeah, I got another 20 to go there. Okay. No bother. As usual, when you finish cut, something goes wrong, doesn't it? I forgot to disengage and might have cut the last thread out. 860, bang on the nose, absolutely bang on. You see that? I'm sure you could see what it was at 860. 860, bang on the nose. Ow, 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 right in the side of my finger. So let's get this boring bar out of the way. And see if the thing fits. It's still in the weight. Straight in. So I went ahead and Loctited the threaded section onto the bar I made a few months ago, and I got an old fixture, don't know what it was for, some kind of mounting for a rail or something, or electrical conduit, or I don't know, and I turned the taper off of it to make it parallel. I turned the two faces, that face and that face, and I bored it out to make it concentric and put a nice tape on the inside and nailed the edge. I have it so it's a close tolerance to the bar as it is, but the only problem is you might notice some scratches on the end here. You probably can't see them with the bad lighting. This goes in now. tight fit all the way down, and that has gone way too far. So I need to mark the length now. Plan of action is I'm going to make a brass bush which is going to go here. I was thinking of using the 3 bolts to bolt it in, but we'll give that a miss. I'll re-rough this edge up a little bit, and I'm going to glue or Loctite the brass bush to this, so when it's tightened up against this flange it's got a brass bearing to draw the collet in. So what I've got to do now is take off the chuck. That's in back gear, that's why it's a little bit rocky. Take off the chuck, stick a collet in, tighten up the drawbar onto it, mark my length, and do that jiggly stuff, which is parting off this bar, boring it out to a thou over that diameter, and then Loctiting it all in with the brass bush on. I've got the chuck off, and this is one of the collets. This is what they look like. And this one just happens to be a 1/16 collet. And that's it all the way in. And to be fair, the collet locks it up, so I don't want it all the way on like that because, well, that has locked it up. So I'm just going to back it off a little bit. By the looks of it, the end of the drawbar can tighten onto the collet far enough to draw it in against the spindle inside where it's bored out. So I don't want that to happen, clearly. I'm going to have to give it some play. That should be fine. I'll show you what that is. You might be upside down now, I don't know. There we go, got a little sharpie mark in there, which is basically in line. And now I've unscrewed it and it is free from the collet, and it's got that amount of thread inclusion, which is approximately just under ½ inch. That'll be just under ½ inch of threads caught on. Yeah, there's oil all over my ruler. And that was with the collet pulled basically all the way in. So I'll just hold the collet and hold it to it. So ½ inch of threads, and the collet itself has just over ½ inch. So there'll be, good grief, let's get this a bit, just under ½ inch. There'll be a few threads that weren't caught onto, which is fair enough. I'm that step closer now to using my collets instead of putting the ER32 collet chuck into a 3-jaw chuck, or dialing it in the 4-jaw, because this is just way easier doing this. So like I was saying, parted off at the mark, bore it out to the right diameter, the right ID, Loctite that in to its full depth. Before I do that, make a brass collar. I think I'm going to make that around about an inch long. Put the brass collar on there. Bore it down to an inch. Sorry, face it, turn it down to an inch so it's a bearing on the inside of the spindle to line up this when it's going in. So when it's near enough all the way in, the bearing on this side will have gone into the spindle and stopped the slop of this. And well, I'm just going to do that. I can't think while I'm doing a video at the same time. But hopefully now I'll be able to push this in through the spindle and have it come out. And then this bush will stop it from wiggling inside the spindle. And after I've done all that end work on that, I'll be able to push it back out of the spindle. Let's see if I can do that. Should be able to. You're going to come through. It's just a bit hard getting it through. Yeah, get it through there. No, can't get it through. It won't go through. This doesn't go through the spindle. I thought it did, but it doesn't. No, it doesn't go through. Alright, so I'm going to have to put the steady rest on again. No worries, steady rest is going on. So I've brought you in a little bit late maybe. I've just cut the section to length, just approximately 1.4 inches. And now I've just spaced it off, and now I'm just drilling it basically. This is 870 something. I've got some bigger drills, but I can't be bothered to get them out basically. So we're in back gear now. That's an extremely large depth of cut for this machine. It's approximately 140, 150, 130 per side, something like that. It's over 100 thou per side. Let's see how she gets on. She started alright, whether she's going to carry on I don't know. Too fast. the chips out a little bit. Hopefully that didn't break my carbide. Nope. So that was quite a deep cut. Extremely deep cut. And the size we ended up with, let's get this out a little bit more. $807. I just wrote it down so I don't forget. So we've got 60 to go. So some gears engaged. Right, let's get my tailstock out of the way. And everything else out of the way. Oh, everything's going to fall off as usual when you're trying to do everything at once. And let's see if the bar fits. I have to take the tool holder out. Is the tool holder going to be enough? No. Yeah, it should fit. I've got to get it straighter than that. I'm pretty certain that's going to be good. Just give it a measurement. Ooh, I did that, didn't I? That's 69. Yeah, that's definitely gonna fit. Definitely. No doubt in my mind that will fit. Okay, let's bring it out. Let's see if it fits. Put that to 0. Zero that out just in case I need to come back to that setting. But I'll wind it out of the way. I've got a 0. doubt I'll need to get it out of the way. There we go. Yep, just a little bit of wiggle room, straight in. So I can glue that on there now. First I've got to cut this off. Yeah. I'm going to clean all this brass up into my brass bin for a start. That's why I cleaned the lathe for a start. So I've got all this brass, let me just show you that. So we've got a pile of brass there, there's some of the shavings. That's how wide the deeper cut, the depth of cut was when I was just plunging the bar in. Focus on that. That was over 100 thou. Depth of cut 200 and something thou each. Total material removal in that bar. That's what they look like. So as per normal, I forgot to get the camera out again. I'm using my 12mm boring bar with an extra sharp bit in it, and I've got the steady rest set up. It's clamped tight, it's squealing at high speed. I've had to do this in back gear to stop it from squealing. I tried putting some weight on it to stop the squealing, but it was no good, so I had to slow it down to around about 100 RPM, maybe less. So I'll give it a quick clean up, just to clean it up. And I measured I needed 12 thou to come out, so just dialed in 12 thou, and now I'm at the measuring stage. And I thought to myself, I haven't even recorded this, so I can't get the measuring devices in with the boring bar in, so I took the boring bar out. So hopefully it hasn't gone too wild. No, it hasn't. 803. 804. Yeah, so I'm getting 803, 804. So I need 6 thou more to come out. 6 thou more. Just double check that and make sure. 809, yeah. It's 810. A bit of thou clearance. I don't know what's happened there. It was going in, there we go, it's gone in. So I'm going to run it through at the same setting again, just to make sure that it hasn't gone in a different position. That's the speed we're running at. Get some cutting oil in there. Engage the feed. It takes forever. Is it cutting? Yes, it is. Theoretically, this should have been the right setting to take out the 12 thou, but it didn't. It took out like 6 thou or something. Maybe because I dialed in 6 thou. Again, I've got this at a 5 thou per revolution step over. I'd say it's doing 100 RPM. It's got an inch and a half to go, so you know, it's going to take a long time. It takes an awful long time. About 3/4 of an inch to go. Yeah, it cut some. I want to see what it cut. Could still solder it as well, but the likelihood of that happening is low. Yeah, that's alright. It's pretty tight. Yeah. Okay. She's in. If I'll just move the steady rest a little bit, get this out. It's a bit tight, but that'll be right. This will go on here. It says it will. I promise you it goes on there. Bit of a burr, isn't there? I'll take that burr off. So that'll go on there. And then that will push in there. I was thinking about bolting them together. They're all going to be Loctited in. And I was thinking about bolting them together like that. Then the general gist of it is I'm going to, from around about 8mm in from the aluminium, screwdriver. So from where the aluminium starts, the brass will be at its full diameter, approximately. I might tone it down a little bit, but then from about 8mm onwards, it's going to be 1 inch in diameter, just under 980, I think it was. And so that's going to be a bearing which sits inside the spindle, and then that's going to be the bearing that butts up against the spindle. So there we go, it's all clamped up. Got the steady rest out of the way, ready for tomorrow, just slide it back into position. And then I'll be turning this. I mean, I've got a centre now, I've got a lot more rigidity with a centre. But I may leave a steady in here just to steady it up a little bit, I don't know. I don't think it'll harm anything, is it, having extra stability. So I think I'll set it up around about here somewhere, give myself a bit more space. And turn this down. So before I put this together, I put Loctite inside the pipe and wiped it around the inside. I put Loctite on the shank of the aluminium plug. I put Loctite inside the bore on this and on the flange. Or I put some on the aluminium flange as well, wiped it around the flange, wiped some around this flange here, and I wiped on the outside of the pipe. Then I slipped the brass on, put the aluminium in, pushed them together, quickly got it into the live centre, tightened the 3-jaw chuck up pretty tight, put some pressure on, locked it off. You can't turn it. You can't turn the live centre. Or you can hear the gears rocking, and it ain't hitting the. It's not hitting the compound slide, or you might think it's in the compound slide. It's not. It's the gear it's rocking in. It's in back gear, so there's a bit of backlash. So I've got the final turner operation on my drawbar, and I think we're going for 989, 990. I got there to around about 10 mil. So I can do a facing cut after I've done that. Yeah, it's about 9.5 mil if I bring up to that line. If I clear the line off, that'll be 9 mil. If I just touch the line, that'll be 10 mil. Clear the line's about 1 millimetre. So I'm going to try it at this low speed for a start. A touch off. to take a quick measurement, see how much I've got to take off. Going to around about 990. I've got 1560. 1560. So we'll zero it out at that. Here we go. Let's try a bit faster on this one. I'm going to try a 20 thou depth of cut, 40 thou total removal. So that's not going to happen because it's going to take absolutely forever. What I think I'm going to do is I'm going to do a gear change. I've got it set up for cutting 24 TPI. That's so I could do the threads at the front of this. But what that gives me is a minimum of 5 thou per revolution. Now I can bring that down to half that, 2.5 per revolution, but I've got to do a gear change. So I'm going to do that and then we'll carry on. Right, we're back. Now I'm down to 2.5 per revolution. Let's have a go at that. 20 thou depth of cut. About exactly an inch and 2 thousandths. Just took it off its mood, obviously. 1 inch and 2 thousandths. So I want it down to about 90. So let's knock on 5 thou. 1, 2, 3, 4, 5 thou. as well. I'm surprised after taking such thick cuts on it. Oh, good grief, you're joking, that's just at exactly an inch. Come on. I took 5 thou off of it, surely. Still 0. Obviously didn't take anything off on that light cut, did it? No, still 1 inch 5 thou. So, got my tool post, oh good grief, let's set the camera. I've got my tool post holder in, and I'm going to be using that, which is my 45-degree tool. I touched it up yesterday when I was doing a job, so it should be pretty honed. I have a little bit too much stick out this time, just to make sure I've got some clearance. 5 thou per side. I haven't got right into the corner there, but I am not fussed about that little bit in there because there's a chamfer inside the Ujima flop, the spindle. So we've got 993 now. I'm going to leave it at that. Probably polish it a little bit with a bit of sandpaper. We'll put some chamfers on. Let's see what I'm doing. I'm touching. Nice big chamfer on that one. And a chamfer on that one. There we go. Still wondering whether I should take some off the outside of that, but that'll be alright. He says confidently. I would like to say this is the first time I tried this, but I just had way too much excitement and stuck it in already. So here we go. In she goes. Tight fit as you can hear. And yeah. Just the slightest bit of play in there, that's alright. Cool. I now have a Collet drawbar because now I can make things like that. This is awesome. I've seen these advertised, right? So I've seen bars like this advertised for Atlas lathes and other lathes about on eBay, Gumtree, you know, and other places. And do you know how much these things are? They're going for about $200, about 190 quid, 180 quid. Is it $239 plus shipping of $60 to get to the UK? It's like, whatever. So this here, that was a axle out of a running machine which has been chucked out on the side of the road. This here was part of the frame of a go-kart that was being chucked out on the street. This here is a bit of CR21 brass which I bought, and that there is an aluminium, I think it's a wire conduit holder, or it could be a metal frame holder on the side of a wall. Free again. So the only thing I've paid for is that bit of brass. And the rest of it, well, there's a bit of Loctite holding it all together. It's amazing what you can do when you've got a lathe. You can take a piece of scrap aluminium, face it off so it looks pretty, both sides. Disregard the 3 holes that are in it because, well, you know, they're equally spaced out. Bore the centre out so it's nice and smooth. You can get a reality of how smooth that is. I've got quite a good finish using that geyser. It's a bit matte, but it's okay. Put 2 radius curves on the outside of it. You can see those radiuses. And then give it a good deep knurling. Didn't have to do anything after that. After putting a knurling on it, just feels right. It just feels great. The edges are rounded over. It's just turned out great. I thought it was going to turn out horrible. Can't believe how well that knurling turned out. Then I turned all the paint and rust off of that steel tube, and it got a lot of chatter. You can see all the chatter marks in it. Look at the chatter in that. But not to worry, it gives it some character. Then I parted off that axle. I bored it out. I gave it some internal threads. Also got some swarf in there. Just need to get it out. Got some internal threads. Bored out the other side to fit the bar. Loctite it out. Left that to dry overnight. Loctite with that stuff on that end. Left that to dry overnight. And turned this brass down.